All right. I hope my screen is visible. Okay. So, today we will be dealing with a quantitative aptitude of your general test part, and we will be talking about time and work. So, when it comes to time and work, there are mainly type, two types of question that they may ask. One is time, speed, and distance, which we will be covering next week. And the another one is time and work. I choose time and work first because it's fairly easier to explain, and the complexity of question cannot be that high. So we will deal with time and work first. So we will straight away begin with the class. Okay. Uh, this is a few example of how they can ask you time and work question. Let's say the first example or the first case which I have given here. A person completes a job in 4 days. Now, what does this imply? It takes some time to complete some job. Usually, there will be no, what I can say, a numeric value attached to the work. Sometimes there might be, like, suppose a person has to lay 100 bricks. So in this case, laying 100 bricks would be his work, and then we will be given some rate of work which he does. So there might be he puts 10 bricks in an hour. So how many hours will it take? Similarly, here we have been given just he completes one job. Now here we start with an assumption that job is basically 1 unit. You need to complete 1 unit of work in 4 days. So if I can write here, just a second. Yeah, if I write here, uh, 1 unit of work in 4 days. That means how much work will I do in one day? In one day, I am basically completing 1/4 of my work. So when it comes to various sums, we won't be able to compare between unit, neither between the days. What we can compare is work per day. Work per day is basically your efficiency. Now, one person, a person A who is very skilled, he can do maybe half of the work in one day, while some other person, person B, who is not very skilled and trained, he will do only 1/4 of the job on one day. So, who is better? The first one, of course. So, when you will be comparing or when you will be solving sums, we will always be interested to find work done in one day or work per day. We can also call it as efficiency of a person. We have another example which says a tap fills a tank in 20 minutes. Now, again, here, tank has some capacity. Let's say it is a 100-liter tank and it takes 20 minutes to fill it. So I can get some rate of work or efficiency, how efficient is my tap. Uh, if it fills 100 liters in 20 minutes, we can find how much does it fill in 1 minute. So work per minute here in this case. All right. So work per minute here will be given as 100 upon 20. It's work upon time. All right. In some cases where you don't have any capacity given, you just assume whole tank as one. Like if it is fully filled, 100% filled, then we say the work is one. So here the efficiency would be 1 by 20. All right. Then, uh, third one says two people finish a work in 4 days. Now, what we do usually from a basic logic or a what we call a directly proportional relationship. We say if 2x people take 8 days, so how much will x take? If it is a direct relationship, we can say x should take 4 days. However, work and time have an inverse relationship. Just excuse me for 1 second. Yeah, I was telling that work is inversely related to time. So, in this case, if I have two people who finish the work in 8 days, then a single person would take 16 days to finish the job. It is very important to understand this logic in order to move ahead in time and work. So, the more number of time, uh, I can't say it's an inverse relationship straight away. I'll try to explain it in some another way. So let's say you take more time to do a work, then you are less efficient. If you take less time, then you are more efficient. Now, in all the questions which we will be solving today, all the questions which will be coming in your exam, you will be most interested in finding the efficiency. Let it be efficiency of a tank, let it be efficiency of the laborers or the workers. So you would be mostly interested in finding the efficiency. If two people take 8 days to finish work, then the efficiency of each person would be, let's say they two people complete the work in 8 days. That means in one day they complete 1/8 of the work, correct? And this is for two people. So if I say one person at a time, so it will take 1 upon 16. How did I get 1 upon 16? I simply multiply it by 1 upon 2. So this is my days, total number of days taken, and this is total number of laborers. All right. I'll explain this logic at detail when we solve some examples. Uh, one more uh, one more correlation or a relationship which you should remember is work is directly proportional to number of men working days and working hours per day. We will be solving very dedicated question to these sort of, where you will be given that let's say 8 people who work 10 hours each day complete their work in 15 days. Now they will ask, suppose there are 10 men working 12 hours each day, then how will I get how many days will they take? So in that case, you will have to use this relationship where you multiply these three, number of men into days into sorry, into working hours per day into number of days, and you multiply this thing and you can eventually find out the sixth term. All right. So let's straight away get to the questions now. I'll explain the theory with the examples here. All right. A can do a work in 21 days and B in 28 days. So let's say A does in 21 days and B does in 21 days and 28 days. So let's find out their efficiency. So efficiency of A is nothing but 1 upon 21. Uh, you simply take a reciprocal of it. Let's say they have to do 1 unit of work together, whatever it might be. So it takes 21 days. So he does 1 by 20th of the work in one day. Similarly, B does 1 by 20th day, 1 by 20th work in one day. Now they are asking us, if they work together, how many days will they take to complete? uh, oh, I had efficiency of A as 1 upon 21 and efficiency of B as 1 upon 20. So when they ask you, they work together or they collaborate, or one person does not work with another, something like that, you will always have to do some addition or subtraction, but not of the number of days, neither of the work. The addition and subtraction will be performed on their efficiency. So let's find out how much work A and B can do together in one day. So it will be nothing but 1 upon 21 plus 1 upon 28. If I solve this, I can take 7 common, 1 upon 7. And if I do a cross multiplication, this will be 4 plus 3 upon how much? 12. So eventually this 7 and this 7 will cut out and I'll get efficiency as 1 upon 12. That means A and B together finish 1/12 of the work in one day. So how much time will they take to complete full work or the whole work? The answer is simple. You just take a reciprocal, will be 12 days. All right. I'll re-explain the logic. I have been given that A takes 21 days and B takes 28 days. So I can find their efficiency. Once I find their efficiency, they are it's the question says they are working together. So I add the efficiency of both of them and I get their combined efficiency per day. So this is nothing but work per day. So I get they finish 1/12 of the work in one day. So how many days will they take? 12 days. All right. I hope the logic is clear. Let's solve one more problem to make it even further easy. Okay. A can do work in 12 days with the help of B. So now we have been given the combined efficiency together. You can write it as 1 upon A or 1 upon B and A plus B, anything. It's just a denotation or it's just a symbol. It doesn't really mean anything. It's just how you use it for your ease. So let's say A is efficiency of B and sorry, A is efficiency of A and B is efficiency of B. So they are telling us the combined efficiency is 12 days. So per day is 1 upon 12. This is efficiency. Right? Now they are saying he can do the work in 10 days. Sorry, I read the question in the wrong way. A can do the work in 12 days, and with the help of B, he can do it in 10 days. So A plus B is 1 upon 10. Now the question asks us, in how many days can the B alone work? So the answer is very simple. You just substitute this value in this. So the equation will be 1 upon 12 plus B equal to 1 upon 10. So B here will be 1 by 10 minus 1 upon 12. So if I take 120 as LCM, it will be 12 minus 10 upon 120. It will be 2 upon 120. So I'll get 1 by 60. All right. So in B can alone finish the work in 60 days. All right. The key learning which you need to understand is when A works alone, he takes 12 days. When B works alone, he takes 60 days. However, when they work together, they should take less time, which is 10 days. If you get the logic behind this concept, like why we need more time, why we need less time when we have more number of people. Always keep this logic in your mind and you will never go wrong in time and work question. All right. Okay, let's move ahead. A and B can do a work in 12 days and 20 days respectively. A started work and left after 3 days. Okay. And B immediately took over and worked till completion. So now here we have something I can say as a phase work. Like first A is working for some period. Here it's 3 days. And then for rest of the time, I have B working. Okay, so here we will have to check how much work is done. We can divide how much work is being done. So maybe I can create something like a table here. A, the work starts with A. This is work remaining. This can be days, number of days. So for first 3 days, A is working. What's the efficiency of A? 1 by 12. So he does one twelfth of the work in 1 day. So he works for 3 days. So basically he has finished 1/4 of the work. At beginning we had, let's say, one, or I can also denote it as 100%. And now 1/4 of work is done by A in 3 days. So I am left with 75% of work, or 3/4. Now B takes over. Now I don't know how many days B works. B works for a few days and his efficiency is 1 by 20. He works for, let's say, X days, and he has completed the whole work. It's written he worked till the completion. So the work he has covered must be 3/4, and at the end the work remaining will be 0. So this is the equation which we are interested in. So if I solve this, I'll change the color of my pen. So if I solve this, this will be 5, this will be 1. So I'll get my X as 15. So for first 3 days, A finished 1/4 of the work, and in next 15 days, B finished 3/4 of the work. Together, they completed the whole job. Now the question asks me, in how many days was the total work completed? So total work was completed in 3 plus 15, which is 18 days. All right. I hope the logic is clear. You can expect such question in your exams. These are fairly, it's just one step higher in the terms of difficulty or level of difficulty. But if you practice more and more sums, you can solve it within seconds, I can see. All right. Always look out for what is asked you in the question. At some times, they will ask you for how many days did B work. In that case, the correct answer would be 15. If they ask you for total number of days, the answer will be 80. All right. Let's move ahead. A and B can do a work in 6 days. B and C in 8 days, and A and C in 12 days. So I can say A plus B, the combined efficiency is 1 by 6. B plus C, combined efficiency is 1 upon 8. And A plus C, combined efficiency is 1 by 12. Alright. The question asks me, if all three work together, in how many days will be the work completed? Now this is a very simple, I can say, a linear equation problem. You just add all of three. So I can adding three equations. I'll get 2 times A plus B plus C equal to 1 6 plus 1 8 plus 1 12. I can take the LCM as 120. So this will be 20 plus 15 plus 10 upon 120. Wait, this will be 30. How much will it be? Yeah, 50. So if I quickly solve it, I'll get the total as how much? 45 upon 120. If I cancel out by 5, this will be 9 upon 24. So this is again by 2. So Yeah, this is twice the efficiency. So we divide by 2 once again. I'll change the color so that if I overwrite it's visible. So the efficiency which I'll get will be 9 by 48. All right. And if I do this is efficiency. Efficiency when A, B, and C are working together. So how many days will they take? It will be simply 48 by 9. All right. This was work per day, and this is total number of days. Okay. What we did, we just defined three equations as per the given information. We add them as linear equations. The only key here is just you have to take reciprocals. If you take 6, 8, and 12, then you will absolutely go wrong in this question. Okay. I hope the answer is clear to you for this question. Okay, let's move ahead. A, B, and C can complete a job in 15 days. B, after working with B and C for 5 days, A leaves, and then B and C take 20 days more to complete the job. In how many days can it should be A, right? In how many days A can complete the job alone? Okay, I'll just make that edit right away. Yeah. In how many days A can complete? Okay. So what we have been given A plus B plus C in terms of efficiency is 1 by 15. It says that after working with B and C for 5 days, A leaves. So basically all three have worked for 5 days. So for 5 days, the work done must be 5 into 15, 1 by 15, which is one third. So one third work is done. So work remaining is two third now. Right. And now they say B and C take 20 more days to complete that job. Okay. So how can I find the efficiency here? Uh, if you recall, I'll erase this. What was efficiency? Efficiency was work per day. So here the work is 2 by 3 and number of days is 20. So if I solve this, I'll get how much? 1 by 30. That means uh, the logic here is if they did two-third of the job in 20 days, had it been the whole job, they would have taken 30 days. I hope you're clear with this. जब बी और सी ने काम करना शुरू किया तब ए ने ऑलरेडी वन थर्ड मतलब उन तीनों ने मिलके वन थर्ड ऑलरेडी खत्म कर दिया था. नाउ ओनली टू थर्ड ऑफ द जॉब वाज रिमेनिंग एंड दैट टू थर्ड ऑफ द जॉब वाज completed within 20 days. So if there was no work done at all at that point, B and C would have taken 30 days. So I can write this and erase it here. So I can write the joint efficiency of B and C is 1 by 30, while the joint efficiency of A plus B plus C is how much? 15 days. So now you can solve for A. A will be simply nothing but 1 by 15 minus 1 by 30. And make space somewhere else. Alright, so if I solve this will be 2 minus 1 upon 30. So 1 by 30. So this is efficiency of A. So number of days will be simply a reciprocal, which is 30. So correct answer is option D. Okay, I'll repeat this question once again. It was given that B, A, B, C together complete the job in 15 days. The three worked together for 5 days. In 5 days, they completed one third of the job. Now, two-thirds of the job was remaining, which was completed by B and C in 20 days. So, if they can complete two-thirds of the job in 20 days, they can complete the whole job or the 100% of the job in 30 days. So, we got the efficiency of B plus C equal to 1 by 30. We already have this equation given from the first statement. And then we simply substitute the value and get the value for efficiency of A, and reciprocal of 1 by 30 gives us the number of days A would alone take to complete the job. Okay, I hope the logic is clear. Okay, moving ahead. Next question. Okay, a team of laborers promised to complete a piece of work in 10 days. So let's say here I have to find the original number of laborers. So let's say there were X laborers first, and they promised to complete the work in 10 days. So what was the efficiency of each laborer work per day per laborer? Here we are not just interested in per day work, but also per laborer work. So this is nothing but 1 upon 10 into X, because let's say X laborers can complete the work in 10 days. So that means X laborers complete 1/10 of the work in 1 day. This is 1 day. So how one laborer alone can finish the job in 1 upon X. This is 1 day, one laborer. All right. So here we are not just interested in work per day, but work per day and per laborer. Okay. Now the question says, but 5 of them do not come. So now I have X minus 5, and these X minus 5 laborers complete the work in 12 days. So what's the efficiency for these people? It should be 1 upon 12 into X minus 5. Find the original number of laborers. So here the efficiency per day has to be equal. Now why it has to be equal? That's a little tricky part. Uh, Basically, how much work we are using the same laborer, so their efficiency per day should be equal. That's a simple logic. Or if I divide total work by number of laborers and number of days, it should be same as in any other case. Let's say a hypothetical situation. I hired 10 men to do a job. 10 men were doing the job in 10 days. Now I hire 10 more. So 20 men can do the job in 5 days. So eventually, if you take a multiplication of these, it will come out to be equal. Okay, so basically the work efficiency per day per laborer should be equal. So now you can solve this equation to get the answer for X. X was our original number of laborers. So if you take a cross multiply, this will be 12x minus 60 equal to 10x. I do a cross multiplication. So I can get 2x as 60. So my x will be 30. So originally 30 laborers were hired, and they promised to do the work in 10 days, but then 5 of them did not show up, so it was 25 who worked, and they finished the work in 12 days. The correct answer in this case is option D. All right, I hope the logic is clear. The Again, the key concept here is you need to remember the work per day per laborer will be equal in any case. Let's say it had been given that 10 laborers did not come. Then they would have taken few more days, let's say 15 days. This is just a hypothetical situation. We may not get the answer for this solution, for this question, sorry. So what would be the efficiency? The efficiency would be 1 upon 15 into x minus 10. And this would be same as these two. Okay. I hope uh, my logic is clear here. Okay. Now this is related to the relationship which I gave you. The relationship was M1 D1 H1. M2 D2 H1. No, this is not related to that. It is a simple question. Sorry. 10 men can complete a work in 18 days. So what's work efficiency per day per men? So it is 1 upon 18 into 10 for 18 days. So they do 1 by 18th work. 10 men do 1 by 18th. So one man does 1 upon 18 into 10. So 1 by 80th, 180th work. After 6 days, 5 more men join them. In how many days will be the remaining work completed? So after 6 days. So for 6 days, I have this efficiency for 6 days. Work is how much? Work is efficiency into number of men working into number of days. See, each each man in one day can do 1/88th of the work. I have 10 such men for 6 days. So work done will be 60 upon 180, which is one third. So in 6 days, my already one third of the job is done. Now I hire 5 more men. So how much work? The work has to be two-third because that's the work remaining, right? I'll change the color here. Yeah. So how much work is remaining? Two-third. Two-third work has to be equal to efficiency into number of men, here 15, into number of days, which I don't know in this case, which is X, and which is the exactly what I have been asked. In how many days will the remaining work be completed? So you can solve this pretty easy. If I divide by 3, I'll get the 60. If I divide this, I'll get 44 here. So X equal to 8. All right. Correct answer is option C. You just need to find the work efficiency per day per man, uh, and then just simply go with the flow of the question and you will get the answer. All right. Okay. I'll before I what whatever we did till now was an flow where few people did some work, then maybe we just have to calculate directly how many number of days they have taken, or maybe A started the work, then B joined, C left, A joined. They can make it complex only in that way. All right. Now this question is your related to straight away that relationship. M1 H1 D1 equal to M2 H2 D2. So the question says 12 men can do a work in 15 days, working 8 hours per day. So I can calculate work. Work is how much? 12 men for 15 days, 8 hours per day. So this is, I'll get some value for this. Similarly, now they are asking me in how many days 9 men can do the same work in 10 hours per day. So 9 men, I don't know the number of days, can do it for 10 hours. Here the work is same in both the cases. That's why we get this relationship. So if I write it here, so I can write 12 into 15 into 8 equal to 9 into. So this is the relationship you want. Either you straight away remember this, or you can just work it out. It's fairly easy. So if I divide this by 9. So 3, this is 4. That's 3. And 3 cancel. 2, 1. So I'll get x as 16. Alright. So 12 men did the work in 15 days for 8 hours day. If I reduce the number of men, so number of men is reducing, their number of hours is increasing, so number of days will also increase from 15 to 16. Alright, they can also ask you how many more number of days will they require. So in that case, you simply do 16 minus 15, which is 1. Alright, this is not given in the question, but they can make it tricky by in this way. They can ask whether you require more time or less time or exactly same time. Alright, okay, moving ahead with the next question. A hostel has a provision for 800 men for 24 days at 2 kgs per man. So we can calculate total consumption or how much food is required, total consumption I can say. So 800 men for 24 days consume 2 kgs. Now they are asking me for how many men is the provision sufficient for 20 days at 1.5 kgs per man. So this is X for 20 days and 1.5. So here you can see the number of days has reduced and also the uh, rate of consumption has also reduced. So number of men should increase. Then only it will be equal, right? So I can write 800 into 24 into 2 equal to X into 20 into 50. So I can straight away cancel this with 10. I'll cancel 1 0 for 1.5. I can do it by 3, so this is 0.5 and this will become 8. If I divide by half, I'm dividing by half means basically I'm doubling it. So it will be 80 into 16 2x. This is nothing but 1080. Alright, x equal to 1080. So that means 1080 means the provisions are sufficient for 1080 number of men. Alright, you can cross verify by multiplying it once again. So if you do 1080 into 20 into 1.5, you will get it same as this. Alright, fairly easy question. This was again related to that relationship MDH equal to MDH. Just here, instead of number of hours per day, it was food per day. It doesn't matter. The logic remains the same. Okay, 20 men can complete a job in 12 days. 4 days after they started working, uh, I think something is missing in the question. I think something is missing in the question. How many joined is missing? Okay, I'll correct this question and tell you maybe at the end of the class. We can for now we'll skip to next question. Pipe A. Okay, this is related to your pipes and cisterns part. Cistern is basically a container of water or any other liquid which you want to store. All right. Pipe A can fill a tank in 8 hours, and pipe B can fill that empty the tank, empty the full tank in 15 hours. So if I have a tank, let's say, I'll have an inlet pipe, which is pipe A, and it takes how many hours? 8 hours to fill. And I have an outlet pipe B, which takes 15 hours to empty. So how much of the tank is emptied in 1 hour? For B, it will be 1 by 15, and for A, it is 1 by 8. Now, a key observation which you should always remember, there can be a question something like this. Let's say in a hypothetical situation, A, which fills the tank takes 10 hours to fill, and B, which empties the tank, takes 8 hours to empty. Now I open both the pipes simultaneously. Will my tank ever get filled? The answer is no. Why? Because per hour, for every hour, I'll get, let's say, 10 units inside, 1 by 10 units of inside, and 1 by 8 outside. That means my outlet is more than inlet. So in that case, the tank can never be filled. In another ways, if I'll erase this, if time of empty pipe, let's say it's emptying pipe, is less than time of filling pipe, then pipe can never be, tank can never be filled. Here we are assuming that both the pipes are opened simultaneously. All right, just similar to the time and work question we did, we will calculate rate of inflow or inlet and rate of outlet. And these two rates will give us outflow or outlet. These two will give us how much time it is taken to fill the tank or empty the tank, whichever is asked in the question. Okay, pipe A can fill the tank in 8 hours, so its rate or efficiency is 1 by 8, 1 by 8 of tank per hour. And for B, it is 1 by 15 tank per hour. Now the question says both of them are open together. So you simply do A plus B, which will be 1 upon 8 minus 1 upon 15. Now why minus? The minus is because inflow we can say as a positive, or it is addition in the tank, while outflow is a subtraction, or we are removing water, so we take it as minus. All right. So if I solve this equation, what will be the LCM? It will be not 60, it will be 120 straight away, I guess. Yeah, this will be 15 minus 8 upon 120. So this is 7 upon 120. So this amount of water is filled every hour. So how many hours will it take? It will simply 120 upon 7. So whatever is this value, it will be somewhere around 50, 17 point something. So it will take approximately 17 hours to fill the tank. All right. I hope you got the logic here. Uh, Additionally, we can have something where you can be defined with the capacity of tank. So let's say capacity of tank is 100 liters. Pipe A empties 10, fills 10 liters per hour, and pipe B empties, let's say, 4 liters per hour. So you can find how many hours is required. You can find number of hours. If they have given you number of hours and not the capacity can be asked. Like if you have all these 3 out of this 4, you can easily find out the fourth value. All right. So the net effect here is 6 liters per hour inflow, and then you divide 100 by 6, so you will get the number of hours. Okay. There can be alternative questions like this in your exam. I don't think I have any, I covered any question of capacity of a tank in this set. So kindly go back and solve few questions on that so that it will be easier for you to grasp the concept. Okay, let's move to next question. Two pipes can fill a cistern. Cistern, as I said, is a container of fluid or a liquid. Two pipes can fill in 12 hours and 18 hours respectively. So let's say it's pipe A and B. A's efficiency would be 1 by 12 and B's efficiency would be 1 by 80. The pipes are opened simultaneously, and it is found that due to a leakage at the bottom, it took 48 minutes more to fill the system. So let's say there is some leakage. See, I don't know its efficiency. That's exactly, I think, what they have asked. In what time will the leak empty the tank? They are saying that there is some leakage, so it's taking more time to fill. Had If there was no leakage, it would have taken 48 minutes less. So I can find out how much time would have it taken if there was no leakage. A plus B. This is simply how much time it will take to fill if there was no leakage. 1 by 12 plus 1 by 18. The LCM is, I think, 36. Yeah. 3 plus 2 by 36. This is 5 by 36. Or I can write it for number of hours. 36 by 5. So this will be approximately 7.2 hours, which is 7 hours, 12 minutes. You multiply 2 by 5 into 12, so you will get the answer. 1 by 5 into 60. So it's taking 7 hours and 12 minutes without the leakage. Now what I have been given that with leakage, it takes 48 minutes more. So with leakage, so I'll change the color. With leakage, so A plus B and some leakage which is minus C, which I have assumed. So here the minus means the water is coming out of the tank. So I am taking 48 minutes more. So I am taking 8 hours, 8 hours. So efficiency would be 1 by 8. You know, now you have found this equation and you already know this equation. A plus B is 5 by 36. Can you solve for C? I'll if you have noted it down, or you can pause it and take a screenshot. I'll erase this and write it because since there's no space to write. All right, I'll erase. So I had A plus B equal to 5 by 36, and I got A plus B minus C as 1 by 8. So I can substitute this thing as 5 by 36 minus C equal to 1 by 8. So my C will be 5 by 36 minus 1 by 8. I think 72 is the LCM here. So y is 10 minus 9 upon 72. This is 1 by 72. So this is the efficiency. So number of hours would be 72 hours. All right, option C. You can expect questions like this in your exam. These are fairly good questions to be asked. Okay, let's move ahead. I did this question. All right, I think that's it for today. I'll just give me 2 seconds. I'll quickly check this question. Where is it? Yeah, I'll just check this question and we'll solve this. Just give me 2 minutes. Okay, so question says that 12 more men joined them. So I'll make the correction. 12 more men joined them. So 20 men can complete a work in 12 days. So what's the efficiency work per day per man? It's simply 1 by 20 into 12, 1 by 240. 4 days after they started working. So for 4 days, how much work could they have completed? 1 by 20, 1 by 240 into number of men into number of days. So it is 80 upon 1 upon 240, which is one third of the work. They have completed one third of the work. 12 more men joined them. So now I don't know the number of days. 12 more men join them for let's how many? 12 more would be 32, and I don't know the number of days. And they have completed the rest of work, which is two-third of the work since one third is already done. So can you find the x here? I'll write it separately here so that it's easier for me to solve. Okay, this is 32 by 240 into x equal to 2 by 3. This will be 80. This 2 and 32 cancel out to become 16. I can take again divide by 4. So this will be 4 by 20 again by 4. 1 by 5. So 1 by 5 x equal to 1. So x has to be 5. So they take 5 more days to complete the job. All right. You can expect such question in your exams. These are, I mean, these are frequently asked questions. Which the only like the logic remains the same. Only the values here will change. All right. To make it more complex, they can give you two phases. Let's say for first 4 days they worked, then for next few days, let's say next 3 days, uh, 18 left them, and then they solved something like that. All right. So as we come to end of the class, I'll quickly revise what we did. Yeah, we did this questions. First type of question where we find efficiency of men and simply find out number of days. Like you can add their efficiency, you can subtract together, or maybe together is given, individual is asked, individual is given, together is asked, something like that. Then we did something which had phases of job to be done, like first few days A worked, then B and C worked, then A and C worked, so something like that. And then we did questions related to this relationship, MDH relationship, I can say. And in the end, we did some pipes and cisterns question. All right. These are the only key four types of question which can be asked you in the question. So go home and practice few more questions on this topic to make it even more strong. And I wish you all best of luck for your exam. That's it from my side. Thank you.